Is there another planet that's very close to Earth, kind of like us, where there could be a civilization?
Yeah, I mean, the closest star system to us, Proxima Centauri, actually has a fairly Earth-like planet around it. We don't know quite how Earth-like it is, but it's called Proxima B.
The James Webb Telescope has revealed something horrifying on Proxima B, signs of chaos and destruction no one expected. But now new data shows it's anything but safe, raising chilling questions about what's really out there. Could this be a glimpse into our own future, or something even darker? Let us uncover the shocking truth about Proxima B that is driving Earth to the brink of total collapse. Lights on, Proxima B leaves scientists stunned. Proxima B is the closest exoplanet to Earth, orbiting the red dwarf star Proxima Centauri, just over 4 light-years away. This super-Earth has intrigued researchers since its discovery in 2016, primarily because it lies within its star's habitable zone. This means conditions might exist that could support liquid water, a key ingredient for life as we know it. However, recent observations from the James Webb Space Telescope have painted a far more complicated and alarming picture. Before we delve into this, it's clear that what the James Webb Telescope uncovered on Proxima B is far more disturbing than anyone could have imagined. And the shocks don't end here. Unlike Earth, Proxima B is tidally locked, meaning one side perpetually faces its star while the other is in eternal darkness. Initially, scientists theorized that advanced life forms, if present, could have developed technologies to transfer energy between the day and night sides, perhaps using solar panels or artificial lights. It was an exciting notion until Webb's sensors began picking up some unexpected signals. The idea of detecting artificial light on distant planets has long been considered a potential method for identifying technologically advanced civilizations. Using its incredibly sensitive instruments, Webb captured faint but unusual light emissions emanating from Proxima B's dark side. These signals bore striking similarities to the kind of artificial light humans produce. While it's tempting to conclude this as proof of alien technology, the reality is far more complex, and perhaps more frightening. Scientists analyzed the patterns of the light and found irregularities that don't align with natural phenomena like volcanic activity or auroras. If these emissions are artificial, it suggests the presence of a civilization that is, at the very least, as advanced as ours. However, what kind of society would thrive under such extreme conditions? And more importantly, what else might they be capable of? Proxima B's environment is no paradise. The red dwarf star it orbits is known for violent solar flares, which could strip away a planet's atmosphere over time. These flares bombard the surface with intense radiation, creating a landscape that's harsh and unforgiving. Yet, if there's life there, it has likely evolved to withstand or even harness these conditions. This raises unsettling questions. Could such a civilization view Earth as a resource-rich haven in comparison to their hostile home? And if they've developed the capability to survive on Proxima B, how advanced might their technology be? Adding to the intrigue, a narrowband radio signal, resembling the type used in Earth's communication technologies, was detected coming from Proxima B in 2021. This was no ordinary static. It carried a specific frequency that hinted at its artificial origin. Although further analysis has yet to definitively confirm its source, the possibility that it's a message from an intelligent civilization cannot be ruled out. What's particularly unnerving is that the signal didn't just appear once. Subsequent observations revealed recurring patterns, almost as if the source was trying to establish contact. But are they reaching out in peace? Or could this be something far more sinister? As scientists dig deeper, the implications of these discoveries grow increasingly ominous. The potential artificial lights on Proxima B's dark side suggest a level of technological advancement that could surpass our own. If these lights are indeed from a civilization, what's their purpose? Are they merely a means of survival, or do they signify something more? Humanity's history is littered with examples of exploration turning into conquest. As we gaze at Proxima B, we must consider how advanced civilizations might perceive our own. If we've detected them, chances are they've noticed us as well. And given the fragile state of Earth's environment, would they see us as a civilization worth preserving, or merely another obstacle in their path? What we've learned about Proxima B opens up new ideas and warnings, making us wonder how these discoveries could change everything we know. The rising stakes in Proxima B's discoveries. Webb's findings highlight a sobering reality. The search for extraterrestrial life is no longer just about curiosity. It's about preparing for the unknown. Proxima B might not just be a distant, uninhabited planet. It could be a harbinger of what's to come, a glimpse into a future where humanity is no longer alone but faces challenges far greater than we've ever imagined. The James Webb Space Telescope's work on Proxima B is far from over. Future missions aim to gather even more detailed data, including atmospheric composition and potential biosignatures. These efforts will require unprecedented precision and collaboration, as the stakes couldn't be higher. Proxima B's radio signal detection highlights just how far science has come and how much further it still has to go. The possibilities are enormous. Astronomers continue to fine-tune their methods, using Webb's capabilities to decipher Proxima B's atmosphere. They aim to determine the presence of specific gases, such as carbon dioxide, methane, and water vapor, the building blocks of life as we understand it. Understanding Proxima B's potential habitability is not just an academic pursuit. It forces us to rethink our place in the cosmos. Should we eventually confirm the existence of advanced life forms on Proxima B, what would that mean for humanity? Would it unite us, or would it deepen existing divisions? Meanwhile, scientists are grappling with the enormous challenges of interpreting data from light years away. With Webb's ability to analyze faint signals, astronomers can separate natural phenomena from potential artificial emissions. This meticulous work ensures that any conclusions drawn are based on solid evidence, not speculation. The discoveries made by the James Webb Space Telescope about Proxima B are part of something much bigger. Scientists are looking at exoplanets like Proxima B, not only to search for signs of life, but also to learn how planets are formed and how they change over time. For hundreds of years, people have been fascinated by the idea of life beyond Earth. But exploring these possibilities also brings up deep and difficult questions. How should we approach the unknown? What might it mean for us to find life elsewhere? Proxima B is close enough to Earth to make it a top choice for more research. This planet gives us a rare chance to study something that could forever change how we see the universe. What if there are intelligent beings there? How would we try to communicate with them? And perhaps the hardest question of all, should we even try? Just because we can doesn't always mean we should. The James Webb Telescope has given us an incredible new way to look at the stars and beyond. But with every discovery comes a growing list of questions. Proxima B could be just the start of what we uncover in space. As we look deeper into the universe, we may find both answers we've been seeking and challenges we've never imagined. Each new discovery is like opening a door to more possibilities, and some of them could completely change how we understand our place in the cosmos. The lessons we learn from Proxima B will help guide us as we keep exploring what's out there. Science isn't just about finding answers. It's also about knowing which questions to ask. The search for life beyond Earth isn't just about curiosity. It's about expanding our understanding of who we are and where we fit in the universe. This exploration is bound to push us beyond our limits, challenging our ideas and shaping the future of humanity. As we keep moving forward into space, Proxima B will remind us of the importance of thoughtful exploration. It's not only about what we find, but also how those discoveries affect us. What does it mean to find life on another planet? Could it change how we treat our own planet? The search for life among the stars may redefine what it truly means to be human and force us to think in ways we never have before. Space exploration is more than just a scientific mission. It's a way to push the boundaries of what we know and what we dare to imagine. And as we continue to unlock the universe's many wonders, we are not only shaping our future, but also learning what it means to explore with care and curiosity. Our search didn't end with Proxima B. It has stretched over years, showing us planets in a universe that's much more complicated than we first thought. The golden age of exploring planets. The history of exploring our solar system is nothing short of mind-blowing. For thousands of years, we've stared at the stars, wondering what's out there. But it wasn't until the last few centuries that we began to unravel the bigger picture. Once the 1950s hit, it was game on. Robotic spacecraft became our way of extending human curiosity beyond Earth, kicking off a new era of discovery. Back in the late 1950s, The United States and the Soviet Union were locked in a fierce competition to explore space. Both nations aimed their sights at the moon. The United States had a rough start. Its early Pioneer missions faced hiccups, with 4 failed attempts in a row. But they didn't throw in the towel. By 1959, Pioneer 4 broke through, escaping Earth's gravity and gathering data as it passed by the moon. Meanwhile, the Soviet Union's Luna missions were making waves. Luna 1 zipped past the moon, Luna 2 smashed into its surface, and Luna 3 sent back the first ever images of the moon's far side, giving humanity a new perspective. Then came the 1960s, and space exploration hit another level. In 1962, NASA's Mariner 2 made history by successfully flying by Venus, revealing critical details about its atmosphere. 3 years later, Mariner 4 took the spotlight with the first flyby of Mars, snapping photos that showed a cratered, rocky surface. This shook up earlier ideas of a lush, Earth-like Mars. It wasn't just a red dot in the sky anymore. It was a fascinating world begging for more exploration. The 1970s and 1980s turned out to be golden decades for space exploration. NASA's Viking program landed 2 spacecraft on Mars in 1976, searching for life and studying the planet's geology and atmosphere. While no signs of life were found, the data gathered was groundbreaking. The Soviet Union didn't hold back either. Their Venera missions to Venus achieved some incredible milestones. In 1970, Venera 7 became the first spacecraft to land on another planet and send data back, even under Venus's extreme heat and crushing pressure. Later missions painted a vivid picture of Venus's hellish landscape, complete with molten rock and sulfuric acid clouds. If the Viking and Venera missions were impressive, the Voyager program was nothing short of epic. Launched in 1977, Voyager 1 and Voyager 2 rewrote the book on the outer planets. Voyager 1 captured stunning details of Jupiter and Saturn, including their moons and ring systems. Voyager 2 went even further, visiting Uranus and Neptune, the only spacecraft to ever do so. Along the way, they discovered 48 moons, active volcanoes on Jupiter's moon Io, and brand new planetary rings. Even after their primary missions ended, the Voyagers kept going, sending data from the edge of the solar system. By the 1990s and early 2000s, space exploration was in full swing. The Galileo spacecraft, launched in 1989, gave us a closer look at Jupiter and its fascinating moons. Europa, with its icy surface and possible underground ocean, became a prime candidate for future missions searching for life. Then came the Cassini-Huygens mission, a partnership between NASA and the European Space Agency. Reaching Saturn in 2004, Cassini unveiled the planet's stunning rings and strange moons. Its Huygens probe even landed on Titan, Saturn's largest moon, revealing lakes of liquid methane and a dense orange-tinged atmosphere. Asteroids and comets soon joined the list of targets. Japan's Hayabusa missions successfully brought back samples from asteroids, providing a window into the early days of the solar system. The European Space Agency's Rosetta mission took things further, orbiting and landing a probe on a comet. Imagine chasing a speeding ice rock through space and actually landing on it. The data gathered from Comet 67 PP Churyumov-Gerasimenko was like peering into a cosmic time capsule. Mars, though, has always been the star of the show. NASA's rovers, Spirit, Opportunity, Curiosity, and Perseverance have been rolling across its surface, uncovering evidence of ancient rivers and lakes. Perseverance, which landed in 2021, is taking things up a notch by collecting samples that might one day make their way back to Earth. And let's not forget Ingenuity, the little helicopter that proved powered flight on another planet is possible. That's a giant leap for drones everywhere. Space exploration isn't just an American story. Other nations have made incredible contributions too. China's Chang'e program has pulled off successful lunar landings and even returned samples from the moon. India's Mars orbiter mission, affectionately called Mangalyaan, delivered key insights about Mars's atmosphere, all on a budget that would make Hollywood jealous. And Europe's missions, like Rosetta and Mars Express, have added layers of understanding to our cosmic map. What's next? The focus is shifting to icy moons and sample returns. Jupiter's moon Europa, with its hidden ocean, is a hot target for missions like NASA's upcoming Europa Clipper. Mars is set to send its first rock samples back to Earth, possibly unlocking clues to its ancient past. And beyond that, who knows? With advancing technology, there's no telling how far we'll go or what we'll find. One thing's for sure, the exploration of our solar system is just getting started. Even with all we've found in space, the biggest questions about the universe still leave us searching for answers to things we don't yet understand. The universe's most unsolved problems. The universe is a massive, chaotic place, and there's no denying that it's packed with unanswered questions. Take dark matter, for instance. It's like the invisible glue holding galaxies together, but no one knows what it's made of. Scientists have thrown around ideas like WIMPs or axions, but they've got nothing solid. It's almost frustrating how much we know it's there without knowing what it really is. Then there's dark energy, which is a whole other headache. This stuff makes up most of the universe and seems to be pushing it apart faster and faster. How does that even work? We call it energy, but honestly, that's just slapping a label on something we barely understand. It's a cosmic shrug, and scientists are left scratching their heads over it. In the Big Bang? Sure, we've got a basic sketch. Everything exploded out of a tiny, hot, dense spot. But what lit the match? What came before, if anything? And where's it all headed? Eternal expansion, a big crunch, or something in between? It's like reading the first and middle chapters of a book without any idea how it starts or ends. Galaxies themselves are a mess of unanswered questions. We've got the basics down. Clouds of gas collapse, stars are born, black holes grow, but the details are maddeningly unclear. Why do some galaxies look like spirals, while others are just blobs? And what's the deal with supermassive black holes sitting at the center of nearly every galaxy? Are they puppeteers pulling the strings of galaxy formation, or just side effects of the cosmic chaos? Speaking of black holes, they're like nature's ultimate riddle. You toss something into one and it's gone, poof, at least from our perspective. But where does that matter go? Does it pop out somewhere else? And the singularity, the point where everything gets crushed? What even is that? Physics just breaks down at that point, leaving us with wild theories and zero answers. Life beyond Earth? Don't even get started. We've been looking, listening, and guessing for decades, and still no hard evidence. If life is out there, why haven't we seen it yet? Are we the lucky ones, or are we just looking in the wrong places? It's like searching for a needle in an infinite haystack without knowing if the needle even exists. Time and space are no less confusing. Is time travel possible? Are there extra dimensions we can't perceive? We live inside space-time, but we barely understand it. It's like trying to explain the ocean while standing in a puddle. Ordinary matter is supposed to be the stuff we know best, but even there, we're missing pieces. There's a chunk of the universe's matter that's just not showing up. We call it missing baryonic matter, but really it's just more stuff we can't find. Neutrinos, tiny particles that barely interact with anything, are another scientific headache. They're everywhere, yet figuring out their exact mass and role in the universe is like trying to solve a problem with half the pieces missing. The process of star formation is another area where we're left guessing. We know stars are born from collapsing clouds of gas, but why do some stars end up massive while others are tiny? And why does the same rule book for star formation seem to apply everywhere in the universe? It's baffling. Cosmic inflation is widely accepted, but what caused it? Imagine the universe expanding faster than the speed of light in its first split second. What drove that burst, and what made it stop? It's like hitting the gas on a car and then slamming the brakes, but with no explanation for how either happened. Cosmic rays, high-energy particles zipping through space, are another unsolved problem. Where do they come from, and how do they get so much energy? These particles could help unlock things about the universe, but right now, they're just adding to the pile of questions. Gamma-ray bursts are like cosmic fireworks on steroids, but we don't know what's setting them off. Are they the death throes of massive stars, or something even more extreme? The energy they release is mind-boggling, and figuring them out is like trying to decode a cosmic Morse code. Interstellar dust and gas might seem boring, but they're crucial for star formation. Where does all this stuff come from, and how does it behave? It's like trying to track the ingredients for a recipe across a chaotic kitchen. Exoplanets, or planets outside our solar system, are turning out to be wildly diverse. Some are scorching hot, some are frozen, and a few might even be habitable. But how do they form, and what makes them so different from each other? It's a giant guessing game. The idea of multiverses, other universes existing alongside ours, is tantalizing and frustrating. If they're real, how could we ever prove it? It's like trying to see outside a box you're stuck inside. The hunt for a theory of everything, one idea that ties together all of physics, feels like chasing a mirage. General relativity and quantum mechanics don't play nicely together, and finding a unifying theory might be the toughest challenge science has ever faced. Gravitational waves, ripples in space-time, have given us a new way to observe the universe. But we're just scratching the surface. What other sources of these waves might exist, and what can they tell us about the cosmos? Neutron stars, remnants of massive stars, are extreme in every way. They're dense, strange, and almost incomprehensible. Studying them pushes our understanding of matter and physics to the edge. The large-scale structure of the universe, with galaxies clumping into clusters and voids stretching between them, raises big questions. What shaped this cosmic web, and what does it tell us about the forces at play in the early universe? Planetary systems, including our own, still hold plenty of questions. How do they form, and why are they so different from one another? Even the rings around planets like Saturn are still confusing. Magnetic fields are everywhere in space, but their role is often unclear. How do they influence star formation or galaxy dynamics? We know they're important, but the details are murky. Fast radio bursts, quick flashes of radio energy from distant sources, are among the newest cosmic problems. What's causing them, and why are they so brief? It's a question that's still wide open. The cosmic microwave background, the faint glow left over from the Big Bang, is like a baby picture of the universe. But interpreting every detail of it is a challenge that keeps scientists busy. Is Proxima B a warning for Earth's future? Or could it hold answers that we're not ready to face? Share your thoughts and remember to like and subscribe for more.